classes by PHSO. So today's topic is Jetstream. This topic is important because of following factors. When the air navigator want to use the plane track path, so they use the jet path. Number one. Number two, even the meteorologists want to forecast the weather condition. So for them, the jet stream's location, which is tracked through the satellite system, is important. Even why the air pollutants get dispersed all across the earth away from the sources like the cities or the industrial units. So reason again is the jet streams. So you heard in the news the concept of polar vortex movement over the poles. There is high pressure systems on the ground and the low pressure system in the upper atmosphere existing, that is trapping the colder air around the poles, and this concept called polar vortex. Why this polar vortex movement take place? And the answer is again is been defined by the polar the jet stream concept. Ozone hole over the Arctics and Antarctics are existing, and it increased in the winter season. Why? So again, the answers appear to be caused by the jet stream. So dynamic mechanism of Indian monsoon we heard. So why Indian monsoon was dynamic? Because of the variation in the timing of rainfall, amount of rainfall, even the withdrawal system, even the onset of southwest monsoon, earlier arrival, late arrival, drought and flood. All this dynamic character cannot be explained by the static thermal concept. Okay, we need a jet stream theory to explain this entire southwest monsoon as well as the winter northeast retreating monsoon or even the western disturbance phenomena. Now, this concept of jet stream is also utilized to explain is formation of cyclonic and anticyclonic system in the mid latitude and the higher latitude regions. Okay, now if you are observing the storms in the tropical, subtropical, even in the higher latitude regions, and these storms are called as extratropical storms, which has been caused because of jet stream phenomena. So all these issues is all are connected to the concept of jet streams. Now question arise, what are jet stream? So jet stream is the fast glowing wind in the upper atmosphere like a ribbon. You can see through this sketch. Now around the poles around 60 degree you can see this is a jet stream which is moving from west to east in the north pole, and when they are moving it is dividing, splitting, or even they joining again and again, and it is forming a meandering path. So because of the meandering path, sometimes low pressure is developed, sometimes high pressure is developed, and as a result the weather system is of the region has been influenced or affected. Now we want to see the details how this process happens. Where are the jet stream? So technically speaking, is it the ground air condition or upper atmospheric condition? Answer is it is an upper atmospheric condition. Now look at this, how this concept has been discovered or originated. So during the Second World War, when the planes are moving across the Pacific from American side to the Japan side to launch the a bomb there, okay, or coming back from the Japan, crossing the Pacifics to the America, the plane speed get changed. So what they observed, when the planes are moving from the American side to the Japan side, the speed has been decreased. So there is something in the air which is moving from west to east, and it is restricting the flow of the aircraft. And when the planes are moving from the Japan side towards the American side, crossing the Pacific in this path, so the jet plane speed has been appeared to be increased. That means the speed of the jet stream is increased or decreased because of the jet stream route is from the west to east. When they are following it, speed increases. When the jet planes are moving against the jet stream, speed decreases. So after that, a lot of research has been carried out to identify the number of jet stream, location of jet stream, the nature of jet stream. Let me discover the characteristics of the jet stream. Is the jet stream is only found in the troposphere? Answer is wrong. It is found in the other layers of the atmosphere too, in the stratosphere, mesosphere, even in the ionosphere. Is it only on the Earth? No. It is also found in other planets. It is an atmospheric system. But we are focused mainly on the tropospheric jet stream of great heights. Let's see the general characteristic of tropospheric jet stream. Now, these have been fast blowing air current with an average speed of around 250 km per hour. They move in the direction from west to east mostly, and they are meandering or ribbon type. That means they have a long length with the small thickness and the width, and they shift with the season. Like in summer, they move towards the pole, and winter they move towards the equator. And this position of shifting is both in the horizontal direction with the latitude as well as with the vertical direction with respect to height also. Okay. Now this meandering of the jet stream provide a zigzag path. Such zigzag or meandering waves are called as what? Rose Y waves. Now, jet stream, if you are observing the map of the location of jet stream, roughly they follows the parallel path between the high pressure centers and the low pressure centers. We call those wind that flows parallel to the isobars as what called? Such winds are called geostrophic winds. So that means jet streams are geostrophic in nature. Now the so question is why and where the jet streams have been observed. They are observed at the location where the temperature contrast or even the pressure contrast or pressure gradient is high. So one of the important reasons for the origin of jet stream is the temperature contrasting location or the location of steep pressure gradients. Now, when they are moving from west to east or any direction they are moving, so many number of times they joins and splits into pieces. So again they join. So this fragmenting and joining is a general character of the jet stream. So in which direction mostly the jet streams are moving? They are actually moving from west to east because their eastward flow has been observed. The reason is the I think is the rotation of the earth. And you can understand in the explanation how this is happening. Now, at what height these jet streams on an average have been experienced or been recorded. So on an average height of tropospheric jet stream is at the height of 12 kilometers. Is it always 12 kilometers? No. It can attain any height from 8 to 18 kilometers. Even minimum up to 4 kilometers is also been observed, and maximum it can go up to the 18 kilometers height for the troposphere. So as a result, you can divide the low altitude jet stream as low level jet streams or the and which is at the great height around the 12 kilometers to 8 to 12 kilometers called mid level or high level jet stream. On the basis of location, the jet stream may be called as tropical, subtropical, or may be called as temperate or polar jet stream too. Now observe these characteristics. Now the dimension. When jet streams are moving, they are moving across the globe, and that's why this character is called circumnavigating or called as circular in nature. They are circumnavigating or circular in nature. So that means cover the globe. And what is the direction of the flow? From west to east they are covering. So what is the dimension of it? It is very long, or thousands of kilometers of length, and few hundred kilometers of wide, and 2 to 5 kilometers of thickness. So it appeared like a ribbon which is moving from west to east, which you can see from this sketch. Such meandering character is providing the rose Y wave. Even the questions are asked why the jet streams are called rose Y wave. Answer comes out because of the meandering character. Even why the meandering take place? Because of shifting with the season, shifting with the ground condition, shifting with the altitude also. Now, as the situation of the ground or environment of the ground is transforming, jet stream also shifting, splitting, joining again and again. Because of this, it will attain a rose Y character of meandering character. Now, where are the jet stream in the troposphere? So the permanent jet stream in the troposphere are two per hemisphere. So two in the northern and two in the southern. So it becomes the four jet stream altogether in the globe is permanent. So one is at a 30-degree called as subtropical westerly jet stream or subtropical jet stream. At 60-degree called as polar jet stream or called polar front jet stream. It is both in the northern hemisphere as well as in the southern hemisphere. So two in the north, two is in the south. Total it becomes four jet stream. Is these jet stream are permanent? Yes. These four jet stream are permanent. They flows all throughout the year. Only they changes the position with the season. When summer arrives, suppose summer is in the northern hemisphere, sunlight is here, they shift towards the North Pole. When winters are there, they shift towards the equator. Suppose sunlight is here, so this hemisphere is having summer and this hemisphere is having winter. So as a result of the summers, so jet streams are shifting towards what called towards the pole. Due to winter, they are shifting towards the we call as shifting towards the equator. This is the only shifting of the permanent jet stream in the troposphere you can observe. There are other jet stream also in the troposphere. So what are the other jet stream in the troposphere? So these are most important are the regional and seasonal jet streams. One is called tropical easterly jet stream, which is found around 15 to 20-degree north latitude, which is moving from east to west, which is opposite from the previous permanent jet stream. You can see here it is moving like this. Another one in the African side called as African easterly jet stream that also moving from east to west roughly from the direction of this called Sahara Desert towards the Gulf of Guinea in Africa. It is moving. One more jet stream called Somalian Jet stream is also called by the name called cross sectional or cross sectional equatorial jet stream. Equatorial jet stream. Now there is one more jet streams are observed over the poles at the height of 40 to 50 kilometers, and this is in the stratosphere, that is called stratospheric jet stream, or also called by another name called as polar night jet stream. Now question arises, why these jet stream develop at these locations? Now, so cause is very simple. When two alternate air masses or air cycles meet, then at the boundary, the jet stream develop. So why? Because there exists an extreme temperature contrast. Because of temperature contrast, the pressure gradient becomes steeper and steeper. So if we see the Earth, so because of the Earth general atmospheric circulation, there are three cycles. So 0 to 30-degree, the cycle called as atmospheric cycle called Hadley cell, and 30 to 60-degree called as what? Ferrel cell, and between 60 to 90-degree called as polar cell. And this concept is called tricellular atmospheric circulation system, or also called as trimeridional atmospheric circulation system. Now, so per hemisphere there are three atmospheric cycle: Hadley cell, Ferrel cell, and the polar cell. So as per the definition here, when two alternate air masses or air cycles meet, that means when Hadley cell meet with the Ferrel cell, that produce around 30 degree subtropical jet stream. Location is 30 degree north and south. So similarly, when Ferrel cell and the polar cell interacting around 60 degree latitude, it is producing what called polar night jet stream in both the hemisphere. Now, so at 30 degree we can see one jet stream, as the 60 degree also we can see one jet stream. Now which jet stream is stronger? Wherever the contrast is high, that stream is stronger. So answer would be here what called polar jet stream is stronger than what? Subtropical jet stream, because the contrast between Ferrel cell and the polar cell, the temperature difference or pressure difference is very, very high across the front, across the boundary here compared to the subtropical jet boundaries. Is it clear? Now let's see the details of it. When like just when the air is moving from equator to pole, okay, then in the northern hemisphere due to rotation, Coriolis force generate, and as a result of that, the air which is moving towards the pole due to Coriolis effect, it turns towards the right, and in the southern hemisphere the air turns towards the left, and because of this, a kind of a balance between the pressure